Okay, so the for week one lecture notes, we're going to cover chapter two, which is set theory. All right, and the first thing we need to cover is the terms. So let me go through the terms here. Um, Let me minimize this for a second. What's this here? Let me just pause this for a second. Okay, so there are these terms we're gonna have to know for the first for this chapter or this section. All right, first one is natural numbers. So natural numbers is represented by capital N. Okay, so and it starts with one, two, three, four, and then these are set set brackets, set notation here. All right, so when it asks for the roster form, this is roster form, it's asking for a list, and you would basically list it like this as I have demonstrated here. Okay. Um, if it's a descriptive form, then that means a short statement describing a set. What is a set? Well, they're group items or collection of objects. Objects in a set are called elements. Okay. All right, this second group of terms, I'm sure you've heard them before. Even numbers, right? They're, 2, 4, 6, 8. Okay, and it's represented by this capital E. Right? Odd numbers is represented by capital O, and then they're 1, 3, 5, 7. Right? Dot, 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 dot means it goes on forever. Whole numbers, the way I remember whole numbers is that whole numbers start with zero. Okay, like there's a hole there. That's how I've always remember it. Right? So whole numbers start with zero. So 0, 1, 2, 3, etc. And that's represented by capital W. Cardinal numbers, what that means is the number of elements in a set. All right, again, I'll give a specific example in a second here, but cardinal numbers means the number of elements in a set, and they're represented by n of a. Okay, sometimes that's what it's written as. Okay, and then the empty set, that means it's like a zero with a slash through it. All right, that's what an empty set. You can represent the empty set by this symbol here. Okay. All right, and then the last, again, we'll build on this term page as we go through the lecture. But these are you know, the few we'll start with. The other one are the difference between the equal and equivalent sets. So equal means they have exactly the same members or elements written as A equals B. Equivalent sets means they have the same number of elements or are that's represented by n of A is equal to n of B cardinality. All right. So again, um, we'll do some examples so we understand what the difference are between the equal and equivalent sets. Okay. The table shows the top 10 majors chosen by undergraduate students at a particular university. A, give the set of majors that were chosen by 4,000 to 8,000 students. Use roster form for your set. And B, give the set of majors that were chosen by more than 9% of the students. Use roster form for your set. Now, as you're working this problem out, so quantitative reasoning basically, quantitative means dealing with quantity, right? And reasoning deals with logical thinking. So the majority of the problems we're going to be working here are going to be word problems. All right. So the purpose of the class is to improve your thinking and critical skills. Okay. So we're going to be analyzing graphs, data, all that good stuff. Okay. So it's not your typical math course where it's heavily based on, you know, algebraic equations and things like that, quadratics. Um, but again, it's still math what we're doing, and we do a little bit of algebra in here and there. But again, the majority are tables, graphs, board problems, things like that. Okay. Okay. So I need to be I have to be on a pace here because we do have a lot of problems to cover. Okay. And but anyway, so a lot of students for the first one wrote down Spanish, biology, and nursing. That is correct. Okay. And then for the second one, a lot of students wrote down um, biology, nursing, psychology, and business, and which is also correct. So let's write this down again. They want it in roster form. So let's see. Use the color here. Okay, so for A, hopefully you wrote this down. So we have Spanish. Again, I'm just going to abbreviate here. Biology and nursing. Okay, so this is in roster form. And then B, we have biology, nursing, psychology, and then business. Okay. All right. Any questions so far? Okay, let's go on to the next question then. Perfect. Okay, so this one is descriptive form. So it's a set of even natural numbers greater than or equal to 6 and less than or equal to 10. So again, we're talking about even numbers, even natural numbers, right? So even numbers, as we mentioned in the terminology page, right? There, you mean 2, 4, 6, 8, 10. Those are even numbers, but it's telling us it has to be greater than or equal to 6. So that means it could be equal to 6, all right, but less than or equal to 10. So it cannot be greater than 10. So we have 6, 8, and 10. Those are your even numbers. All right. And again, they want in roster forms, so we just put this in inside our brackets here. Okay. Just like the one over here. Okay. All right. Now this one is in roster form already, so they want us to identify what kind of numbers these are. So again, if you look at the term page, all right, natural numbers start with the one. So 1, 2, 3, 4 to forever. Okay, so in this case, then we'd write down that these are natural numbers. So we would choose natural numbers. Okay. So the first part here is saying let sets A and B be defined as follows. A is a set of integers greater than or equal to -10 and less than or equal to -3, and B are these set of numbers. For part A, it says find the cardinality of A and B. Okay, so again, go back to the term page that we talked about to find out what that word term cardinality means. And then the second part here is asking us to select true or false. Okay, and then we have this symbol, these symbols here. So let me talk about that right now. So this, it looks like an E, like an elongated E, right? This means it belongs to a set. Oops. Okay, or a member of the set. Okay, or it's part of the set. Okay, so think about like, if you have a family and you have, three children. So it's you and your spouse and your three kids. They're all members of that family, right? So if you want to think about it that way. All right, so and then if it looks like again an E and with a slash through it, that means it does not belong to the set, does not belong to the set. So, for example, remember if you watch the movie Home Alone, the very first one, right? Kevin goes missing. They miscounted, or they counted, but they counted the wrong kid, right? The kid that was in the van at the very beginning, the sister counted him, but he wasn't Kevin, if you've seen Home Alone. But anyway, so he does not belong to the family, right? Does not belong to the set. So anyway, that's represented by this slash. It looks like, again, an E with a slash through it. All right, so go ahead and see if you can answer these questions. Okay, I appreciate those who have submitted their answers. So let's go through this. If you're still confused, let me know and I'll try to um, clarify any information. Okay, so here again it says, let sets A and B be defined as follows. A is a set of integers greater than, so this is greater than or equal to -10 and less than or equal to -3. So it says greater than or equal to -10. So the first number, okay, and a lot of you wrote this, is -10, all right? And it's a set of integers. And so it's greater than, so remember the number line, right? You have a number line, there's 0 here, right? And then to the right, you have positive numbers, correct? And then to the left of that, you have negative numbers, okay? So it's telling us that -10 is way out here. Okay. So we're going to go greater than or equal to -10. So as we get closer to the right to 0, the bigger the number, right? So the closer to the left, the lesser the number. So -10 is less than -3, right? So less than or equal to -3. So we just list them. So -10, -9, -8, -7, -6, -5, -4, -3, right? So those are the set of integers, okay, that are greater than or equal to -10 and then less than or equal to -3. And then I can just write that in roster form, right? By just putting those brackets there, okay? So that's what this is saying, okay? All right, and then B, they already told us what it is. So for the first one, A says find the cardinality. So if we go back here to our term page, cardinality means what? It's the number of elements in a set, right? And it's represented by N of A. So that means you just count them, okay? Oops, where are we? Here we go. Okay, so the cardinalities of A and B. So in A, right, the cardinality of A, you just count how many numbers you have. You have 1, 2, 3, 4, 5, 6, 7, 8. So that means here we would have 8, right? So the cardinality of A is 8 because there's 8 elements in the set. There are 8 numbers in the set. Does that make sense? Okay. And then for B here, we just count 1, 2, 3, 4, 5. So that means the cardinality is just 5. Okay. So you have all these fancy things. Math is a lot of these fancy notation, but that's what basically it's saying. Okay. All right. So now the next part here is asking us to select true or false. So is -20 a member of B? Negative. So I go to B here. Here's my B. Is -20 in there? Yeah. -20 is a member. It's part of the set. So this is true. Okay. The next part is -14 a member of A. I go to the A, right? Here's my A. -14 is -14 listed anywhere on this list? Nope. So we say that's false. Okay. 23. 23 is not a member of B. Well, again, I go to 23. Is 23 not a member of B? That's true, right? 23 is not listed there. So that's true. And then the last one, -6, is a member of A, and that's true. Here's -6, right? It is a member of A, so that's true. Okay, hopefully that helps. Okay, for each given set, determine if the set is finite or infinite. So finite means just a limited amount, right? So if you have, soda pop, in a box of soda pop, there's maybe 12 in a pack or six in the pack, so it's finite. Infinite means it goes on forever, right? And it's represented by this symbol, infinite. Okay. So for again, this question is asking for each given set, determine if the set is finite, if it's limited, or if it's infinite. If it's finite, again, give the cardinality. All right, so let's go through this one. All right. So what does if it says a dot 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 after the numbers, what does that mean? Infinite, right? That means this means it goes forever, right? So if there's a dot 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 after that, right, it goes infinite. So that means that this one here is going to be infinite, right? Dot 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 means it goes on forever. Okay. Well, what about the other ones? Well, okay. 1, 2, 3 to 20. So that means we're skipping a bunch of numbers, or it's saying those numbers are already there, right? We're not skipping them. It's just saying, hey, the numbers in between 3 and 20 are listed there, but we're going up to 20. So that means then this is a finite, right? Because there's a number at the end of it. So we would write that will be finite. And then what's the cardinality? How many numbers are listed in there? Well, there's going to be, even though it's only saying four numbers, there's technically 20, right? Because that's what the dot 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 in the middle represents. That's representing all those numbers that are not listed. So the cardinality here is going to be 20. Okay. And then the last part here, the set of odd numbers greater than 18. Well, odd numbers are what? 1, 3, 5, 7. So greater than 18. So that'd be 19, 21, 23, 25, 27, dot, 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 right? It goes on forever. It says the set of odd numbers greater than 18. So that means that this is going to be infinite. Okay. All right. I know let me pause this here. Okay, again, I appreciate those who have submitted their answers. So let's go through these and see if you got them correct or not. Okay. All right. The first one says A is a set of integers greater than 18 and less than 22. So let's go ahead and write those down. So greater than 18. So that means it's 19, right? 20, 21, right? So it's greater than 18 and less than 22. So those are the three numbers there. All right. And then we'll just write in roster form. Okay. So what do we know about these numbers? A lot of people are saying both equivalent and equal. That is correct. All right. Right. Um, Equivalent saying because they have three numbers, and equal because they're the same. Okay. All right. Part B. A is a set of even numbers greater than 7 and less than 13. So greater than 7, so that would be 8, 9, 10, 11. I'm sorry, even numbers. Even numbers. So 8, 10, 12, right? So greater than 7 and less than 13. So those are the numbers that it's talking about in part A. And then part B says B is a set of integers greater than 15 and less than 19. So that would be 16, 17, and 18. Okay. And all right, for the part B1 here, or people are saying it's equivalent but not equal. That is correct, right? They have the same um, number of items. There's three on the first for part A and three on the part B, so they are equivalent, but they're not the same numbers, right? So this is equivalent but not equal. Okay, C. We have CGI, or I'm sorry, CGJ, and then B is PQRT. All right, and a lot of people are saying, um, good. Yes, so they are neither, right, equivalent nor equal. Okay. And then the last one here. Um, these are the numbers for part A, and then these are the numbers for part B. All right. So again, they have this, there are 4 items in part A, 4 items in part B, so they are equivalent. But again, they're not the same exact numbers, so they're not equal. Okay. So very good. So a lot of people are also choosing the first part here for part D. Okay. All right. Questions on these ones? All right, let's do one more here. And that, oh, I don't know why it keeps doing that. So let me just write this out. Okay, this one, so there's going to be 2 sets of numbers here. Again, I'm not sure why it's doing that. We have 4, 5, 6, and then we have 4, 4, 5, 6. Okay, so are these, um, what is this? What do you think this is? So we have 4, 5, 6, and then we have 4, 4, 5, 6. Okay, so we have a mix of answers here. Um, so let's look at this. First of all, in order for them to be equivalent, right, they have to have the uh, same amount of items in each list, correct? So in this case, the first one here, again, we'll label this part A and we'll label this part B. Part A, there's 3 items, correct? And then part B here has 4 items, so they're not equivalent, correct? Okay, so they're not equivalent. Equal means, do they have the same number? Okay, so A has 4, 5, 6, and B also has what? 4, 5, 6. Even though 4 is written twice, listed twice, they still have the same numbers. So in this case, this is equal, okay, but not equivalent. Okay, so again, even though 4 is listed twice in part B, it still has the same numbers as part A, 4, 5, and 6. So again, in this case, this is equal but not equivalent. So equal but not equivalent. Sorry, I know that says equivalent there. All right. Any questions here? Talk about this. Okay, so I'm on slide 9 here. It says in the braces below, list all the subsets of the set 765. Okay. Write each subset in your list in roster form. If there is more than one subset in your list, separate them with commas. If you need the empty set in your list, use the symbol empty set. Okay, so again, I'm going to go through this pretty quickly on this part. So again, we're just trying to list the different combinations of the set here. Okay, so one is we can just write each one individually, right? So I can write 5, right? Or I can just write 6, or I can just write 7, right? So in this case, this is going to be a subset in one element. Okay, it's a subset in one element. Right? Another combination that I can do is I can write 2 numbers in each set. Okay, so I can write, say, 7, 6. All right, sorry about my brackets there. Um, I can write 7, 5. Okay, and I can write 6, 5. Okay, again. Apologize for, there, that should be better. My brackets there. So in this case, this would be what? This would be a subset of two elements now, right? Because again, each of the set has two items. Okay. And then another combination is, well, I can pick all of them, right? So I can pick 7, 6, and 5, right? And we only have that combination. Again, order doesn't matter here. Okay. So this would be a subset of three elements. Does that make sense? Okay. Now, I can pick none of them. I don't have to pick, 7, 6, 5. I can pick none of them. So I can have the empty set, right? I don't like any of them. I'm not going to pick any of them. So this would be a subset of 0 elements. Okay? All right. Question on that one? Okay, let's go to the next slide then. Okay. So let's talk a little bit about the universal set. So think about the universal set like being in the room, okay? So maybe you're in a living room, maybe you're in your bedroom, kitchen, wherever, okay? So in that room, there are a limited amount of items in the room, right? So maybe in the kitchen, you have your refrigerator, you have the stove, you have plates, cups, things like that. So you have all these items, and that will be your universal set, okay, in your kitchen. All right. So what we're trying to figure out, okay, not in the kitchen? Maybe the couch is not in the kitchen. Okay. So you say, well, the couch is not in the kitchen. Okay. Or maybe a mattress is not in the kitchen. Okay. All right. So again, so you have to think about it in the kind of in those terms when we talk about the universal set. So here, the universal set, it tells that these are the letters in the universal set. So that's all the items in your kitchen. Okay. And what we want to do is we want to answer these questions. And the first one says, suppose we know that B prime is equal to GQX. So this little, it looks like an apostrophe. Okay. This is prime. Okay. That's prime. Sometimes it's called complement. 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 Okay. But anyway, so when I say B prime, that means um, we don't want any of this items. Okay. So suppose that we know that B prime is listed here. These are the items in B prime. Then what would have to be in B? Then what would B have to be? So what is that saying? So it's telling us, okay, B prime has this, so that means if I go to the universal set, I'm going to eliminate those items on the universal set. Okay? So G, Q, and X, right? Because they're in B prime. So whatever is left over is going to be in B, in regular B. Okay? So that means what's left over is HPR. So I'm going to list that. H, P, and R. Okay? So again, B, regular B, if it says regular B, that means what's in it. And then B prime saying, oh, well, what's not in it? I don't want those items. Okay? I want to eliminate those items, or those items are not in there. Okay? So, so again, B prime saying these are the items in B prime, GQX, so that means I'm going to remove those items in the universal set, and whatever is left over is going to be in B. So that's going to be HPR. Okay? Let's try it again. So in this case, suppose now C is these items here. Okay? So the items, these are the items in C. So what's going to be in C prime? So again, let's go back to the universal set. I'm going to erase that because this is a new problem. Okay. So again, C is G, Q, R, X. Then what's going to be in C prime? Okay, very good. All right. So we know that again, C contains these elements. So that means I go to the universal set and I eliminate that because I'm trying to figure out what's in C prime. Okay, so I eliminate G, Q, R, and X. What is left over? HP. So C prime is just going to be HP. Okay, so whatever is left over, which a lot of you guys picked. Okay. All right, any questions on that one? Okay, so let's go to the next one. This is probably the hardest one. Actually, let's go to the blood type. Let's do that. Okay, blood type. All right. So, um, it says here the table lists the 8 human blood types. It also shows how blood types determine who a person can donate blood to and receive blood from. Okay, so here's our table. These are the blood types. Okay, and this is so the second column tells us who they can donate to, and then the third column tells us who they can receive blood from. Okay, so for example, uh, let's look at um, A positive. No, I don't want to do that. Let's look at B negative. Okay, B negative says, okay, B negative can donate to these guys. B plus, B positive, B negative, AB positive, AB negatives. So if you have this kind of blood type, then I can donate to you. Okay? This person can donate blood to you. However, um, if I'm B negative, I can only receive blood from B negative and B and O negative. Okay, so if I'm B negative, I can only receive blood from these guys, B negative and O negative. All right, if I get blood from like AB negative or AB positive, then that's going to be really bad. Okay, I can probably die. So I can only receive blood from B negative, O negative. Does that make sense what I'm saying? Okay. All right, so let's look at this. So we have the universal set, right? These are all 8 human blood types in the universal set. All right. It says let X be the set of blood types that A negative can receive blood from, and Y prime be the set of blood types that A positive can receive blood from. Find the sets below. Okay. So I want to pause here for a second. I want you to think about. Okay. So let's go through this. So it tells me, all right, let X be the set of blood types that A negative can receive blood from. So let's go to our chart, right? Here's A negative. Okay. It says, okay, we want, it says the set of blood types that A negative can receive blood from. So they can receive blood from, right? Because here's can receive from A negative, O negative, right? So they can receive blood from there, right? So that's what this is saying. Let X be this, and that's what this is saying. So the answer here for this part is A negative, O negative. Now, what is this asking? X prime. Right? That's going to be the opposite. Whatever is left over, we don't want. So in this case, if X means we can, right? This means can, okay? They can, right? X prime means they cannot. Does that make sense? So if X means they can get it, X prime means, well, I cannot. So if I go to my universal set, okay, again, I can receive blood from A negative and O negative. So I can cross those guys out, A negative and O negative. So, but X prime means, well, I cannot receive blood from who? Then I have to list the rest of the items here. So that would be A positive, B positive, AB positive, AB negative, B negative, and O positive. Does that make sense? Okay. All right. All right. Now let's go to the next part. Let Y prime be the set of blood types that A positive. So let's go to A positive. So here's A positive. And it says cannot receive blood from. So let's go do the opposite. So cannot receive blood from. So who can A positive can? Well, A positive, right? A positive can receive blood from these guys. Okay. And that's what we want because we just have a regular Y. Y prime means cannot, but Y, regular Y means I can. Who can I get blood from? Okay. And that would be what's listed on this chart. So that would be A positive, A negative, 0 positive, 0 negative. Okay, so this next example, I'm describing these two new terminology or notation. So this one looks like an N, that means intersection, and that means both sets have in common. So maybe you're talking to another person, what do you guys have in common? Maybe you guys like watching IU football, or you guys like to go shopping at Old Navy. I don't know, whatever it is. Okay. So what do you guys have in common? That's what this little looks like an N symbol is intersection. Union means it's like, part families, right? They're combined together, right? So maybe you had a previous marriage and you had 3 children with that person, and then the person you're marrying has 2 children. So you're just a mixed family. You're combining together. So you're putting everybody together. That's what this union symbol means. Okay. You group all items together as one set. Okay, so here it says find the intersection of H and M. All right, so I look at H and I look at M. What do they have in common? What would that be? Perfect, right? So this means, hey, what do I have in common with H and M? D. Okay, so I just write D here. All right, it says write in roster form, no problem. That's my answer. Okay. Now, how about it says find the union of H and M? Okay. Now, if the letter or number is written twice, we just have to write it one time. We don't have to write it twice. I know that one previous example had it written twice. Technically, we just have to write it one time. We don't have to rewrite it twice. Okay. So in this one, it says H union M. That means we're just going to combine everything together. Okay. And again, it wants it in roster form. So sure, no problem. So we have C, D, K. Again, it doesn't have to be in order. And then we have AH. All right, that's it. Okay, question on that one? All right, let's try to squeeze in this next problem. Okay, so the next one, this is slide 14. So sets B and C are subsets of the universal set U. These sets are defined as follows. Find the following sets. Write your answer in roster form or as an empty set. Okay, so we're gonna have to draw a Venn diagram here. Okay, so I'm gonna draw a box. And what do you notice automatically between B and C? Do they have something in common? Yes, right? They have 8 in common. So automatically, I'm going to have two circles, okay? And I'm going to overlap them together. Why am I overlapping them? Because I noticed that B and C have 8 in common, okay? So again, this is my universal set, okay? And that's labeled as U. That looks like an M, but that's how I write my U, okay? And then in the middle, I'm going to put 8. Why? Because they have that in common, okay? And then I'm going to have my B and my C, okay? So what do we know about B? B has what? These items, 1, 6, 8, okay? But I know that 8 is shared with C, so that means 1 and 6 have to be outside of C, right? But it has to be in a B. So 1 and 6 go in here. And now for C, we have 4 and 8. Well, 4 is here, okay? But again, it has to be in C and cannot be in B, okay? Does that make sense? Everybody okay with that part there? Okay, cool. So that means then what's left over? What do I put in a universal set? What's missing? 9. Very good, right? Nine's missing because I already accounted for 1, I accounted for 4, I accounted for 6, and I accounted for 8. So the only number that's missing is 9. So it doesn't matter where you put it, okay? I'll just put 9 out there. Okay, so now we have accounted for all the numbers. Do you see that? So this is how we would write if they asked us to write it in Venn diagram, this is how we would write it. Okay. All right, so let's go through this one. So when we solve these problems, we have to think about PEMDAS, not pandas, PEMDAS, right? Please excuse my dear Aunt Sally. So we focus on the parentheses, right? P means parentheses. E means the exponent, and then the rest. Okay, so the thing I want to focus on is parentheses and then exponents. Okay, so um, if I look at this here, I have my parentheses. So that means I need to focus what's inside the parentheses first. Okay, so B intersection C. So what's going to be B intersection C? So again, again, we already draw it here. Okay, so this is one way to show it. But if we didn't have this, because we didn't have that drawing, what is it saying? So B intersection C, we already mentioned that. That was what? 8, right? 8. B intersection C is 8. Okay. So now it's saying, what is this? What is it saying? Prime, right? Prime. That's our exponent next. So we focus what's inside the parentheses, checked. Now we need to focus on the exponent, which is the prime. What does that mean, prime? Well, prime means I don't want anything, I don't want 8. I don't want everything outside of 8. Okay? So everything outside of it. So what would that be? What else? We're missing another one. Exactly, right? So it's saying B intersection C is 8, right? Checked. We know that. Prime means I want everything outside of 8. I want everything outside of 8. So that means if I were to, highlight this, this is everything outside of 8. Okay? That's everything outside of 8. So that would be 1, 6, 4, and 9. Does that make sense? Okay? So that's what I would write here. 1, 6, 4, and 9. So that would be our answer. 1, 6, 4, and 9. Okay. And the last part is B prime. Again, I'm sorry I'm rushing this a little bit because I'm running out of time here and I need to talk about Alex. B prime union C. So again, what do we focus first? We have to focus on the B prime. Why? Because that's in order, exponents. So we have to focus on B prime. So B prime, right? We already said that. Um, that will be everything outside of B. So let me erase this. Oops. There we go. So we want everything outside of B. That's B prime, right? B prime is outside of B. So that would be what? 4 and 9. So B prime is 4 and 9. Okay. And we want union with C. Okay. Well, union and C, again, we already addressed B prime, right? That we want outside of B. So that means here's B. B prime is everything outside. And now we want union with C. Okay, what is C? Well, C is all of this. C is all this, 8 and 4. So we already have 4, so we just need to um, include 8. Okay, so again, C is equal to 4 and 8, right? So we already have 4. Um, we just need to include the 8. So our answer here is going to be 4, 8, and 9. Okay. Okay. Again, if that was confusing, I can go over it a little bit more after, but I have about 6 minutes left.